Okay, hi everyone. I'm here with your 3-2-1 lesson. It is titled How Does It Move? Addition, Subtraction, and Opposites. Follow along as I read your introduction. Do you remember the famous frog jumping contest from Chapter 1? Today you will work with more jumping frogs as you begin Section 3.2. In this section, you will work to solve the problems that involve distances and directions using diagrams and numbers. This work will begin your investigation of integers, positive and negative whole numbers, and zero. So we're going to start with problem 390. 390 says, Elliot is so interested in the frogs that he is developing a video game about them. In his game, a frog starts on a number line like the one below. The frog can hop to the left and to the right. For each part below, the game starts with the frog sitting on the number 3 on the number line. Use your 3.2.1 resource page to answer Elliot's challenges below. Part A. If the frog starts at 3, hops 4 units to the right, to the left 7 units, and then to the right 6 units, where will the frog end up? So go ahead and pause the video and answer the question. So hopefully you kind of use this number line here. So if we hopped 4 to the right, 1, 2, 3, 4, 7 to the left, 1, 2, 3, 4, 5, 6, 7, and then to the right 6, 1, 2, 3, 4, 5, 6, you would see that Elliot's frog ended up at 6. Part B says, if the frog makes 3 hops to the right and lands on 10, list the lengths of 2 possible combinations of hops that will get the frog from 3 to 10. So go ahead and pause the video and answer that question. If you're back with me, that means you have answered part B. We are going to save part B to go over in class. We are not going to do any more of problem 390, but we are going to move on to 391. 391 says opposites. Find the math notes box titled opposites, which follows problem 393. After reading about opposites in the math notes box, answer the questions below. Elliot played the frog video game twice. In each game, the frog made 1 hop. After the second game, the frog ended up the same distance from 0 as after the first game, but on the opposite side of 0. Describe the 2 games. How could the frog start at 3, hop once, and then in the second game, again, start at 3 and end up the same distance from 0, but in the opposite direction as the first game? Give a possible set of hop directions, lengths, and ending points. So you're going to pause the video. You're going to go read the math notes box titled opposites, which is on the back of your notes down here. And then you are going to answer this question. Okay, if you're back with me, you have answered part A. We are going to save it to talk about it in class. Part B says, how would the frog hop to meet the following requirements? From 3, make 1 hop and land on 6. Well, again, if you need to draw yourself a number line, draw yourself a number line. So if we're at 3, we need to make 1 hop and land on 6. So 1 hop, land on 6. So he needed to hop 3 to the right. So from 6, we need to make 1 hop and land on the opposite of 6. So the opposite of 6 is -6, which is all the way down here. So let's see how many we would need to do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So he would need to hop all the way down to get to the opposite of 6, which is negative 6, he would need to hop left 12. So from the opposite of 6, which is negative 6, make one hop to land on the opposite. Oh, I'm sorry, you can't see that. From the opposite of 6, make one hop to land on the opposite of 6. So we have 6. The opposite of 6 is negative 6. The opposite of 6 would be 6, because the opposite of 6 brings you back here. So we have 6, we have the opposite of 6, then the opposite of the opposite, which would be the opposite of negative 6, is 6. I know that's tricky, okay, but it takes us back to 6. So back to 6, he would need to hop right 12. Okay. So part C says, how could you write the opposite of 6 using math symbols? Where would this be on the number line? So I already helped you with where would it be on the number line? It would be at 6. The opposite of 6. So we have the opposite of 6. So the opposite of 6 is negative 6. So that's going to go in the parentheses. And then the opposite of the opposite would have another negative. So we have another negative on the outside, which in turn would also just be 6. Okay, 392. While designing his video game, Elliot decided to replace some of his long sentences describing hops with symbols. For example, to represent where the frog traveled and landed in part A of problem 390, he wrote 3 plus 4 minus 7 plus 6. How does Elliot's expression represent the words in part A of problem 390? Where did the 3 come from? Why is one number subtracted? Part B says if another set of hops was represented by 5 minus 10 plus 2 plus 1, describe the frog's movements. Where did the frog start and where did the frog end up? And then part C says one game used the expression negative 5 plus 10. Where does the frog start? Where does the frog end up? And what is special about the ending point? So you are going to answer parts A, B, and C. And you do not have to do part D on the back. So you are going to part D is not there. Part D is, you do need to do part D and E. Okay, another game had a frog at the opposite of negative 3, hop 5 units to the left, 9 units to the right, and then hop to its opposite position. Write an expression to represent the frog's motion on the number line. Where did the frog end up? In part E, where does the frog start in the expression negative times the quantity of negative 2 plus 6? Where does it land? So you need to do 392 parts A, B, C, D, and E, and we are going to talk about that when you come back to class. If you have any questions, as always, please email me.